Okay, so now that we've got our review all squared away, let's officially start our trig course. So everything begins with an angle, all right? So I think we kind of have maybe a working understanding of what an angle is, but let's approach it from a mathematical thing, and then it turns out that that'll kind of set in motion a whole series of terminology, all right? And a lot of it we'll use throughout the semester. But basically what an angle is we start with which is known as a ray. Right? What a ray is it has an initial point, and from that initial point we start going in some direction. So perhaps my ray looks like that, or maybe my ray looks like it's going down in that direction, or perhaps it's going up in this direction. All right? And maybe it's a little smaller going in that direction. Right? Perhaps it's real tiny, right, going in this direction. So what I have as examples throughout the page there are examples of rays. Right? So a ray, again, it has an initial point, and then it has just a line segment that goes on forever. So we start someplace, and then just move in a direction forever. Technically speaking, if you've ever had a physics class, they're called vectors. So it's a ray is another fancy name for a vector. So the way we start creating an angle is we start going through a rotation. Now there's two ways we can rotate. We can rotate clockwise, right, which is what we're kind of used to doing, starting going in this motion, or we can rotate counterclockwise. And it turns out, sorry if that's a little small, if you rotate clockwise, this is what we call a negative movement. If you rotate counterclockwise, that's what we call a positive movement. So if I wanted to create a positive angle from this ray right here, what I'm basically going to do is take this ray and basically rotate it until it stops. All right, and so notice because of the rotation, the direction has now changed. And what I have here in this little dashed line, that would be our angle. How about I call it theta? And of course, this angle would be a positive angle because my rotation, I'll use another little arrow to represent my rotation. My angle was rotated in a counterclockwise position. So now what we've done is we formed an angle. And what we have is more terminology. Every angle has what we call an initial side or ray, and every angle has a terminal side or ray. And it's essentially because we rotated, we're switching positions. So it's almost like, dare I say, if you've ever been in the military and you're kind of asking to go right or left, and you move in those directions, or maybe you do an about face. Okay, so kind of the idea. So we're looking ramrod straight in one direction, and then we do a rotation with our feet or whatever, and we start going in another direction. That rotation is called an angle, initial side and terminal side. And that pretty much is it. So it doesn't really matter for this one. Let's say I wanted to, again, it's the way the direction is, but the way I'm rotating, let me rotate this, right? So here's my initial side, here's my terminal side, there's my theta, right? And this would be a negative angle because we rotated clockwise, all right? So clockwise rotation has a negative connotation to it, and counterclockwise. And we can do it on and on and on, right? If we went over here and I just rotated that much, right? So there's my rotation, there's my theta, here's my initial side, here's my terminal side, right? And this angle will also be a negative measure because the rotation, right, occurred by forming a counterclockwise, by doing a clockwise rotation from the initial side. All right, and so again, we can just keep playing this all day. So, perhaps I rotate this guy all the way around, so it's now heading in this direction. So there's my theta. This would actually have a positive connotation to it because we rotated, right, in a counterclockwise situation. So that would be a relatively big angle. All right, and so forth and so forth and so on. So, if I rotated this and came in this direction, my rotation went that way, so there's my theta. Because the rotation was counterclockwise, it has a positive connotation, it has an initial side, and it has a terminal side. Right? So that pretty much gets us started with regard to angles. So every angle begins with a ray. We rotate that ray about its point, and then if we did a clockwise rotation, we have a negative measurement. If we have a counterclockwise rotation, we have a positive. Okay? In terms of measure, the way that we measure, oops, better spell that right. The way that we measure angles, there's actually two ways. There's the degree measure, and then later on we'll talk about radians. So right now, since this is kind of new to us, what we're going to be doing, sorry about that, that's a G there, right? We're going to be using the degree measure. This will come later in chapter 3, but there's essentially two different ways that we can measure how far we rotated positively or negatively to form my angle. So we're going to talk about degrees, and let's know what we know, right? We know that if I have an initial ray and I rotate it all the way around, so this time the initial ray and the terminal ray, right, basically are in the same direction. We did a full spin. There's my theta. Well, first of all, that's positive, and we know, right, if you ever played on the basketball court, or maybe you're a skateboarder, right, or maybe you do some skiing and you're watching the X Games, right, a full rotation, when I basically rotate myself so that I'm looking in one direction and I rotate fully so that I'm looking in the same direction, we have gone through a 360-degree rotation. So what this also means then is if I go through 1 degree, right, 1 degree basically represents 1/360th of a full rotation. And so it's actually going to be quite small. I mean, so small, it's going to be hard to measure. So if this is my initial ray and I want to rotate 1 degree, right, that would be the 1 degree right there. It is extremely tiny. As a matter of fact, if I pulled a protractor out, that's probably almost too big, right, because I'm really trying to demonstrate what we have. If we're talking about, let's say, 30 degrees, right, that means that I'm taking my initial ray and I'm rotating it, right, roughly about a 30-degree rotation, which would be 30 over 3/60th of a full rotation. Okay, and of course we can reduce that, and I believe what we get is that 1/12? So it's 1/12 of a full rotation for that, 30 degrees, and so forth and so on. Of course, we can rotate negatively, right? If I had a negative 15 degrees, then that means I would basically take my initial ray, I would rotate in a in a clockwise way, and so we're representing 15 over 3/60th of a rotation. So maybe, it's roughly about there. So there would be negative 15 degrees. So the unit of measure that we'll be using is a degree. Okay, so why don't I go ahead and stop there? That's probably enough for this video. We're already almost at 8 minutes long. So I'll continue to go on this terminology with a new page and with a fresh start. But right now we know what an angle is. We know how to rotate it positively and negatively, and we know how we're going to be measuring them. Right? We're going to be using degrees, and we got that concept. More coming later.